So this is problem 1.6 in Irodov's book of problems in general physics. And the problem statement is that a ship is moving along the equator to the east with a velocity of 30 kilometers per hour, V0. And there's a southeastern wind which is blowing at an angle of 60 degrees to the equator with a velocity of 15 kilometers per hour. Now we have to find the wind velocity V dash relative to the ship and the angle phi between dash between the equator and the wind direction in the reference frame fixed to the ship. So we have a ship which is moving 30 kilometers in the east direction along the equator. So this is a ship, it is moving, so this vector here, this is the velocity vector V0, and this is the direction in which the ship is moving, and the wind is southeastern wind. So a southeastern wind is a wind that is blowing from the southeast. So let's say if this is the north and this is north, this is east, this is west, and this is south, a southeastern wind would be coming from this direction. So here we have this arrow here. This is velocity vector V of the wind which is blowing, and it is blowing at a speed of 15 kilometers per hour, and the angle which it makes with the equator is given to us as 60 degrees. And we have to find the wind velocity V dash relative to the ship and the angle of this velocity. So when we want to find out the wind velocity relative to the ship, what it means is that we have to consider the ship as stationary. So in order to do that, what we do is, this is velocity V0, and we apply an equal and opposite minus V0 velocity in this direction, and that's equal to 30 kilometers per hour, the magnitude, and since the direction is reversed, so this is 30 kilometers per hour, the original direction of the ship. And when we have to find out the wind velocity relative to the ship, what we want to find out is V minus V0. So this is the vector V, which is the wind velocity 15 kilometers per hour, and vector V0, minus V0 is equal to 30 kilometers per hour. So basically it is the addition of these two vectors, V and minus V0. So if we want to add it using the triangle law, what we get is this vector, and this is nothing but vector V dash, which is equal to V minus V0. So this is the relative velocity vector, and we have to find this. In order to find this, let me just construct another line here. This is an imaginary line. I draw it because I want to make a right angle triangle. So let's say A, and this is point B here, and this one is point C. In order to find out V minus V0, so if I want to find out the modulus of this vector, that is equal to the modulus of vector V dash, which is equal to vector V minus V0. So for that, what I can do is the the vector v minus v naught is the hypotenuse AC. If I want to find out the length of this hypotenuse, that would be equal to vector AB squared, so plus BC squared, and the under root of this would give us the length of this hypotenuse AC. And AC is nothing but this velocity that we want to find out, the relative velocity. So let me also call this point as O. We'll need this, and I'll show you why. So here we have AB squared. AB can be written as AO plus OB squared plus BC squared. Now AO is nothing but 30 kilometers per hour. So this is 30, and OB, so this angle is 60 degrees, and OB will be equal to, and this is velocity vector V. So OB is nothing but OC sine 60. And BC can once again be written as, this is OC cos 60 degrees. Sorry about that. This is OC cos 60 degrees, and BC is OC sine 60 degrees, and we find we know the magnitude of OC is equal to 15, so we can substitute that value in this equation to get 30 plus 15 cos 60 squared plus 15 sine 60 squared. Simplifying this, so this will give us 900, 1 plus cos 60 degrees plus 225, and we'll get cos square 60 plus sine square 60 in the brackets here, which will give us a value of 1. Cos square theta plus sine square theta is equal to 1. So we get 900, 1 plus cos 60 degrees and plus 225. Cos 60 degrees is equal to sine 30, so that is 0.5. So 900 into 1 plus 0.5 plus 225, and we get this will give us a value of 1350 plus 225. Let me just add it. We add these two, we get 1575. So this is equal to under root of 1575. And let me just use a calculator to find this out. So this gives us a value of 39.69 kilometers per hour. So this is the magnitude of velocity v dash, which is the relative velocity v minus v naught. So this is basically the magnitude of AC. So this is equal to 39.69 kilometers per hour. Now that we have found AC, the next step is to find out the angle phi dash between the equator and the wind direction in the reference frame fixed to the ship. So the angle phi dash would be equal to this one. So this is the angle phi dash that we have to find out. In order to find that out, we can use sine of this angle. So sine of phi dash would be equal to BC divided by AC. BC was, it is nothing but 15 sine 60 degrees, and we divide it with 39.69, and if we calculate this, phi dash comes out to be 19 degrees. So these, so we've got two answers in this question. The first one is the wind velocity v dash relative to the ship, which is equal to 39.69 kilometers per hour here. And then the second one is the angle which this velocity makes, which is equal to phi dash, which is equal to 19 degrees. Yeah, so that is the sixth problem of Irodov, and we have solved it. And thank you for watching. Please like, share, and subscribe to my channel. Yeah, if you want me to continue making such videos. Thank you.